In this video lecture, I will discuss the steps of T-beam design. So here I already wrote the steps so that I can save some time. Before starting, so this is a T-beam, this portion is plane, this is wave, the wave width is BW, this is the width of the entire beam B. This portion is in compression area of concrete, we call AC. Slab depth is A and the depth of the compression block is A. So you know the symbols by this term. What are the steps? So step number one, calculate dead load and live load. Yes, for any design, you must calculate your dead load and live load by default. In classes, typically sometimes we provide this dead load and live load just to save time. Depending on the test, if our main concentration is in the design, we provide dead load and live load to save time. But in your real life, you must calculate dead load and live load. Okay, there's some discussion on dead load. You know that if I have T beam, say one beam here, other beam here, this is my slab. So if this is my T beam, this beam will take the dead load from center to center. Here center to center to center. That is something to remember. Sometimes this width, this B doesn't go up to center, but your dead load is up to center to center. That is something to remember. Then step number three is size. Size means the size of this wave is commonly known given by architect, or you can choose your size. But this calculation to calculate the B, to calculate the size of B, ACI gave us some recommendation. It is in your book. Very briefly, this B should be smaller of span over 4. Then second condition, this portion cannot go 50% this side, this portion cannot go 50%, more than 50% that side. That means center to center. So I simply call CC. The other requirement is that from this side to this side cannot exceed 8 times the slab thickness, or simply I can tell that BW plus 16 AC. So smaller of this. If I go back to your book, it is in the beginning of this chapter. Yes, it is in the beginning of chapter. So you can calculate your B. Whatever the smallest of this, is B. Okay, that is a different discussion, or you can see your book for this. Okay, I am trying to make this video as clean as possible because so many things. So size, again, most of the sizes will be known. If it is not known, you can select. But for B, you need to calculate based on the ACI recommendation. It is in your book. You can read and select your B or calculate your B. Then step number 4, assume A equals A shape. That means at the beginning we will assume that this depth is up to this or less. So it's somewhere this or less. So that means at the beginning we will assume our compression block is inside the flange, not in the wave. And we will assume phi is 0.9. At the beginning we will assume this. Then calculate AS, mu over P, FYD, A by 2. If a moment you already calculated from step number 2, P you assume 0.9, FY material properties, yield strength of steel, it is known. D is a depth from here to where you will place your reinforcement, that is your D. Now you will decide based on this depth, maybe you will deduct some space here for clear cover or cover, typically 2.5 inch should be good, and that's when this portion 2.5 inch is okay. 2.5 inch is okay. So then you know your D from that. A, you just assume A is ASF. Then you got your reinforcement area. Now this reinforcement area is not a final design. It is based on this assumption. Based on this assumption that your stress block is here. It may be true, may not be true. Okay, then we will calculate. Now we are going to check this value. Calculate concrete comprehension area AC. So that means we are now calculating the compression area, the entire area. ASFY, tension here, compression here. Compression stress times the area. So now, excuse me. So this AC means area. Area means entire area. Then calculate A using geometry. Now, can you do this? If you know the say area here is 200 inches square. If you know this size, B, this width, can you calculate A? Of course. There is no reason that you cannot. Or simply if I go more, say if this distance, first check that if AC, AB, A, and if it is B, okay, I should not do that. B is a, say this distance is X plus X BW is AC. So B ASF is the area of this portion, and for this portion I am assuming X times BW. X times BW is your AC. Then your B known, ASF known, BW known, you can find your X. Then your A will be X plus ASF. So in this way you can calculate your A. Now this A is your revised A. So once we get a revised A, we will not use this A anymore. So we got the A now. Now we will see whether our compression block, okay, let's clean it. Now we will judge whether this A is within the flange or outside flange. So two cases may be possible. One is within the flange, one is outside the flange. So it is in step number 8. If A is equal or less than A shape, that means A is within the flange. What we will do? We will revise our A's. Whatever A's we got here, we'll revise it. A mu, phi, my, B, A by 2. So this AS was based on this A. This AS will be based on this A. Revised A. That means we are revising our reinforcement. Now, if this this reinforcement is close to this, that means that our design is done. We got our reinforcement. If it is not close, that means there is a gap, huge gap. Then we can revise it again. How? We will calculate our revised A using this equation, ASFY. Now, this AS will come from here. Whenever we are getting a revised value, we will use that value. And then we will calculate our revised A. Once we got our revised A, we will calculate our revised A's. Now, this revised one, we will use it here. Then we will get our revised A's. So we did our trial and error. We revised our A's. Then we should check our minimum reinforcement requirement, whatever the ACI course says. You need to check it, but make sure when you are checking minimum reinforcement, that minimum reinforcement is based on this BW, not this. So if you go to your book, make sure there is a in that equation there is a term B or BW. That BW is this for minimum reinforcement. Then you have to check your phi. So you have to check your phi. How to find? You got your A, revised A. Calculate your beta 1. Calculate C. Then tensile strain. Based on the tensile strength, you know how to find phi. You saw this term many times before, so you know how to find phi. Now one question is, if your phi is 0.9, the problem is solved. If your phi is not 0.9, if it is less, then what to do? Then simple, if your phi is less, you have to start from here again, do this portion, trial and error, you have to go back. So if your p is 0.9, good. If your p is not 0.9, you have to go back here and do all this. For minimum reinforcement, if your minimum reinforcement is less than this, if your this reinforcement is less than minimum, you will use the minimum. You cannot go less than minimum. This portion you know it. Now other case, if your A is greater than A shape, A is greater than A shape, that means your stress block is somewhere here. Then what to do? Then it is a real T-beam. So in this case, I will say T-beam. This is a real T-beam. This is actually not T-beam. It is actually rectangular beam. So this beam is actually this. But this beam is actually T-beam. What to do? You have to find the centroid of this area. Centroid of this area. You know how to find centroid from your statics class. Then calculate AS, A mu phi Fy d minus y bar. Why y bar? Because you are no longer using the A by 2. It is, you have to find the centroid, deduct that centroid. Then find your revised AC. That is revise this area. Now why you are revising? Because if you go back, this y bar is actually, there's some assumption here. At the beginning we assumed A is A shape. So there is some mistake, not mistake. There is some flaw in that calculation. So you have to revise it. So we revise AC based on our new AS. Now again there is we can fine tune it more. Now we can calculate revise A based on this area. Once we get A, we can calculate our revised y bar, then revised AS. Now this portion sometimes we skip. This portion sometimes we skip because most of the cases this reinforcement is very close to the actual answer. So I am writing here may skip, but in your real life I do not recommend you to skip to be safe. Yeah? Okay, once you get your reinforcement, check the minimum reinforcement, because whatever reinforcement we are providing, it must be greater than the minimum. Then check your phi, and you know how to check phi. First calculate A, then beta 1 to C to tensile strength to phi. If phi is 0.9 or 0.9, your life is simple. If phi is not 0.9, go back here and do this calculation again. So here I discussed how to design T-beam. You can see here everything is here in a same picture, so that you can visualize what we are doing. So in the next video I will solve examples one by one. See you then.